Machine learning is fundamentally probabilistic and humans are not. So I think there is always going to be an error rate with machine learning techniques as they have currently been developed. Would have to be some kind of other advance, some kind of other technology to act like a human and have actual conscious decision making. It's actually a huge engineering challenge.
All that and more on today's Mixture of Experts. I'm Tim Hwang, and welcome to Mixture of Experts. Each week, MOE brings together a panel of brilliant, funny, and in the case of Chris Hay, somewhat unhinged technical experts to discuss and debate the week's news in artificial intelligence. This week, we've got an incredible panel. We've got Olivia Buzek, Senior Staff Dev Advocate, Chris Hay, Distinguished Engineer, and Mihai Criveti, Distinguished Engineer, AgentKit AI. All right, we've got another packed episode again this week. We're going to talk about radiology. We're going to talk about manifolds. We're going to talk about a huge partnership between IBM and Anthropic, as well as OpenAI's AgentKit release. But first, we've got Eiley with the news.
Hey everyone, I'm Eiley McConnon, a tech news writer for IBM Think. I'm here with a few AI headlines you might have missed this week. Chipmaker AMD signed a deal to supply OpenAI with billions of dollars worth of chips. In exchange, OpenAI could get up to a 10% stake in AMD. Are diamonds a computer chip's new best friend? Companies are starting to embed tiny pieces of synthetic diamond into chips because diamonds are exceptionally good at moving heat. These chips could ultimately help data centers generate less heat, currently a big waste of electricity. This week, IBM introduced Project Bob, a new set of tools for developers to automate complex processes like code development. When 6,000 IBM developers tested Project Bob, their productivity increased on average by 45%. Are you trying to get in shape before the holidays? Bike maker Peloton has introduced Peloton IQ, an AI-assisted feature that acts like your personal trainer. It gives you feedback on your form and suggestion for weights and workout plans. Want to dive deeper into some of these topics? Subscribe to the Think newsletter, linked in the show notes. And now, back to the episode.
All right, so let's just dive into it. So the big news of the week is OpenAI's release of AgentKit, which is really kind of a two-part announcement. They talked a little bit about their new agent builder that they've created, which is sort of a clean sort of user experience for designing agents, as well as a number of updates on its evaluation platform. And Olivia, maybe I'll turn it to you. How big of a deal is this? I mean, I feel like we've really been in the year of agents. It's been a joke on MOE that we say agent repeatedly every single episode. But this builder seems to be maybe the first attempt in my mind to kind of really make some of this technology broadly accessible if you're not sort of technical. Is that right?
I don't know if it's the first attempt, but it's certainly a very strong one. IBM recently acquired DataStax, which brings LangFlow, and LangFlow, I think, brings a lot of that low-code builder experience that you see in the AgentKit into available in open source, and that's something that we're starting to try to integrate into a lot more IBM products as well. And then before that, we see things like Crew AI and LangGraph. LangGraph, I think I would agree with you. It requires much more of a technical edge. But then Crew AI is, as long as you really can write some code, and almost anyone can write some code now, especially basic agent code with, generative AI at this point. You can see people getting agent things across out of the box pretty easily.
And there's, I think, a fun kind of evolution here. And I think you touched on something I would love to get your thoughts on is, I saw this and I was like, oh, it's really funny because with all the stuff that's been happening in code gen, I think we originally had maybe a vision that's well, it's okay. You'll just tell the machine what you want, and then it'll generate the code, and everybody will be able to code is essentially the direction we're going in. This almost seems like a step back, not maybe a step back, but a step in a different direction to say, okay, even in a world of code gen, we will still need kind of a graphic, kind of no-code interface for managing all this stuff. And I guess I'm curious, do you buy one approach or the other, or do you feel like it's still unclear which one's going to kind of win out over time?
Yeah, so I have actually some pretty strong feelings on this because I've been involved in AI in one form or another for about the last 15 years. And pretty much every time we have a big evolution, people are like, oh, the machine learning code, it's going to replace everything. And, it's been 20, 30 years. Realistically, we've had AI in some form since the 1960s, and, it still hasn't happened. It's still there. There was a paper about 10 years ago from Google that put out this very pretty little diagram where it showed that only about 10% of the code of any machine learning system was actually machine learning. And I think that still holds true. In reality, so if you're asking the LLM to do all of your compute, you're essentially saying, okay, I would like the most expensive part of my system to do everything, even if you have a plan in mind. So, let's say that you want it to check your email every morning and look through and find the highest priority items that are in there. You probably don't really want the LLM choosing its own adventure every morning. You probably want it to do essentially the same thing every day. So agent frameworks are really the only way that we can mix that kind of classic deterministic programming with something that's a little bit more probabilistic like this.
Mihai, maybe I'll kick it over to you next. I saw the kind of OpenAI sort of AgentKit sort of experience getting some critique online where people were saying this kind of way of doing this where it's like a bunch of blocks that are all kind of wired together. Like maybe this is like not the most efficient or easiest way of managing this stuff. And so I think like to maybe build off of what Olivia is saying, like I think even if we say, okay, we're going to accept this kind of graphics paradigm, I guess I'm kind of curious about your view of like, is this kind of like blocks and wires sort of, in your opinion, kind of the way we're going to go about visualizing this? Or are there other ways that you think are going to be like ultimately kind of the dominant way we do this?
I think code is there for a reason, and the fact we now have AI doesn't change that in any manner. We've tried to do this before with UML. If you remember back in the day when we used to think that everything could be designed and developed just using diagrams, and there were a lot of products, including from IBM, rational rows and all these other kind of things, with the promise of writing UML as code. You translate from UML to code, from code to UML, and you design everything visually. And it requires specific paradigms like object-oriented languages for this to work. And it sort of worked for, I would say, a bit. But once you went beyond, single developer, small projects, you extended into legacy projects, you wanted to integrate with different systems, different programming languages, a lot of the paradigms broke. We see this with agents as well, where you have platforms like NA10 and Longflow and Flowwise, which take the same paradigm as now the AgentKit from OpenAI, where you have this visual programming language. Now, it's very attractive because even as kids, for example, you typically learn programming visually. So if you've done, turtle programming or Scratch, which is like a visual IDE for kids where you kind of learn how to program using these exact same blocks, or even Node-RED, an open source project from maybe 15 years ago, which taught you how to compose things for the Internet of Things using visual programming languages. It's very attractive. You can get started very quickly. The problem is scaling. Once you go beyond a single contributor, once your project goes beyond a single workflow, once you need to integrate with existing systems, once you need to do things like version control and management, it becomes very, very unwieldy. So I would say it has its place, especially for things like one-off automations where it's one and done. But if you want to build a real application, I still believe there's a strong, strong case to make. You should be writing code to begin with.
Oh, Chris, you want to jump in?
Of course I want to jump in. I'm gonna rebut that a little bit, Mihai. So I think to your point, I'm gonna cover two things. I think the first thing is that I think this is really about making agents available to everybody. And to your point about Scratch, actually, the average human being can go and create agents now in a very, very simple way. It really doesn't take more than 5 to 10 minutes to learn how to use the tool and be able to create an agent very quickly. And actually, if we think about the sort of workflows and the things that people want to be able to do, it is clicky, right? It's like, I want to go and connect to my Google Mail. And there's a connector there available for this. I want to go and write something to Google Sheets, and there's a connector available to this. And then if we think of even enterprise systems for a second, the reality is we want to be able to protect your inputs. So be able to put the kind of the guardrails, on either side of your inputs as well. So that's 2 or 3 blocks. And we have to do that today in enterprise compute anyway. So for the ability for somebody to be able to quickly stick a guardrail in there, maybe do a little bit of routing, and even be able to do multi-agent, right? Because it's just a matter of sticking another agent in there and then connecting them up. I think you're pushing the bounds, to your point, Mihai, of if you are not a coder, that ability, without knowing about tools like Langflow, etc., that you don't really have good ways of doing that for the mass consumers. So I think you're going to get better agents from consumers there. To your point about programmers, I completely agree. I do agree with your point that things get sufficiently complex, and then you're like, I really need a code representation. But then at the same time, what's quite nice about the way OpenAI has done the agent builder is actually built on top of the agent SDK. So if we actually look underneath of the hood of the workflow, actually you have your agent SDK code there, which can be in TypeScript or Python, and you can just take that representation. So you can start with the workflow, but then you can just source control it as code there. So there's nothing stopping you from doing that. So I think what they've done is quite clever, and actually some of the things they've really done well is take away the complexity. So one of the things I sort of panicked at was like, oh my goodness, they've introduced common expression language, right? So if then else's, and I was like, there is no way the average human being is going to be able to understand that. But actually what they've done there is really good, especially for structured outputs, is they just put an LLM in the way, and you just describe what the schema you need is, and then it will go and generate it for you. And you're like, actually, that is a pretty cool technique. So there is complexity in there, but I think what they've done to make it easier is quite useful. So I think I am excited, but to your point, it's just nowhere near as powerful as things like Langflow, for example.
Mihai, maybe a final question to you on this. So I think, Olivia, you kind of called out my original prompt on this being like, well, hold up, this is not the first attempt in the space. There's a bunch of other players in the space. But obviously, whenever OpenAI does something, it's just an 800-pound gorilla kind of moving around. I guess, Mihai, do you ever thought on like how the business strategy of this evolves, right? Like if you're not OpenAI and you're seeing them do this, what's like the next game if you're really trying to compete in this sort of like no-code sort of agent builder kind of ecosystem?
I think what OpenAI has going for them is volume. They have the market. They have hundreds of millions of users and consumers. And they can afford to be slow, introduce features that don't necessarily try to solve everything, but what they solve has a good user experience, is easy enough for these users to kind of understand. And eventually this will make its way towards enterprise systems where the same consumers want to do, for example, citizen automation. And we've seen this before with things like Power Automate, for example, or Excel macros, where the premise was the same, that anyone, or even Lotus Notes, like Lotus applications, any citizen within the organization can go in, can drag and drop a couple of things, can write a bit of automation and do something that's a one-off task, or even turn it into an enterprise application. So I do see how some of these systems could make their way towards enterprise as well. And I do see a business play there. But I think for OpenAI is sufficient just to have their current monetization. And hundreds of millions of users all paying $20 a month is going to be quite substantial.
Well, this is great and a good way to kind of flow into the next topic that I want to cover today. So some other really big news, and Mihai, we'll stay with you because I think like you were directly involved in this, but IBM has announced this strategic partnership with Anthropic to integrate Anthropic into a bunch of its sort of tools and methodology. And I think one of the things, I know you were directly involved in this project that really stuck out to me, and we've talked about it on the show before, is kind of this idea of creating a guide for how you should securely deploy enterprise AI agents. And specifically this idea that we're going to have this thing called the agent development lifecycle, which is going to be sort of a structured way that people should go about doing this. And I find this so interesting because it feels like, we're always talking about agents, but we always focus on the technology. It feels like this is maybe like one of the first things I've seen, although Olivia, keep me honest again if it's not actually the first thing, where it does feel like there's now starting to be a lot more thinking in terms of like, okay, well, what's the whole set of business processes that kind of need to fit around this technology? And so I don't know if you were directly involved in the ADLC ADLC kind of guide work, but if you were or if you weren't, would be curious to get your thoughts.
Yeah, I was. I was working on the ADLC guide as well. So one of the things that came out of that exercise was that agents do need to have their own process, similar to software development lifecycle, but it needs to deal with the the probabilistic nature of large language models and take into account things like, for example, testing and testing of AI agents that needs to be done in a different way. So, for example, true evals. In fact, I believe AgentKit, which was released from OpenAI, touches on that as well. One of the components it starts to offer or add to the mixture is the component of evals. How are you going to ensure that the outcomes of these agents are correct, either in line, so as the agent executes, it can go, oops, that's the wrong result, I'm going to go back, I'm going to retry, or after the agent has executed, I can take one agent, 100 agent executions, and look at the accuracy and look at some of the numbers of these agents. And having a structured, governed process around this for planning, coding, building, testing, releasing, deploying, operating, monitoring the life cycle of agents is important for enterprises. And many of the non-functional requirements, things like encryption, security, and governance, and all the things that come with traditional enterprise software need to be weaved into this approach. And we've seen that today AI agents and AI development is quite immature. And one of the projects we've started in this space is Context Forge MCP Gateway, which supports A2A, supports MCP, and provides support for the agent development lifecycle and agent ops. So we see a similar need. We see that these are things that enterprises are saying must happen before any of these agents are allowed to touch production systems.
That's really that's interesting. So I guess, Mihai, where does it go next, I guess, in terms of this development? Now that the guide is out, is part of this now kind of testing it in the field, or, how do we develop this out? I'm really interested in basically how these processes now become sort of like industry wide, right? We're talking about adoption now.
To build this guide, a lot of folks from IBM had to come together, folks from consulting, from technology, from research. We've collaborated with Anthropic as well. And we've leveraged our experience in both customer engagement. So we've looked at healthcare clients where we've implemented agents. We've looked at telco clients. We've looked at banking clients. But it's just a start. This needs to be an ongoing, evolving process and document. It needs to reflect all the latest and greatest changes in fields like eval. For example, do you trust another agent to evaluate your agent? Does an LLM that evaluates itself have any bias in that evaluation? So all these things need to flow back into the ADLC, and we need to see tools and technologies develop around this. Better evals, better components such as the MCP gateway, components that support, for example, the development lifecycle itself, like, for example, Project Bob, which we've also announced as part of this. So all of this needs to come together into one more cohesive agent ops and ADLC, agent ops platform and ADLC process.
Olivia, I'm kind of curious about kind of the market evolution that a strategic partnership like this signals. I remember it was only I feel like 24 months ago, where there's kind of a vision that it was like going to be one model to rule them all, right? Like eventually you have an AI company that creates like such a powerful, capable model that everything else follows suit, right? But it does seem like not just Anthropic, but all the big kind of AI players are kind of thinking about how partnerships work in the space, which sort of suggests to me that like a company like Anthropic is saying, well, we want to get into enterprise. We don't really know a whole lot about enterprise. Like IBM knows enterprise, so we have to partner. And so does this mean that like the industry is ultimately going to be characterized by a lot more partnerships over time than this kind of original model, which is, okay, it's one AI company and they kind of end up controlling everything? It feels like this is going to be more multipolar than we thought. Is that the right way of thinking about what's happening here?
Yeah, I think it's an interesting point, especially in context of the agent development questions that you were having before, where basically I think what we're seeing is that LLM engineering is a lot more complicated than we initially thought. As you have said, originally we kind of thought, hey, we'll just hand all our problems off to an LLM. The LLM's going to, LLM is clearly just as good as a person. We can just have it do anything and it's going to all work out great. And I think we're finding that that's not 100% true. And there's also some theoretical limits that I think we're starting to bump up against a bit when it comes to sheer LLM training. So what that means is either people need to partner or they need to get really good, each in their own realm, solving all of the same problems that Mihai is discussing. So, I as a I've recently been looking at the this space as it pertains to how do you look at the use cases for agents, basically. And I think it really divvies up into two things. One is you're automating a piece of your own work, or you are automating a process for the business. And right now, a lot of the agent world has focused on how do you automate things for yourself. And that's cool. That's a little bit labor saving. It's definitely going to be helpful for people. And yet at the same time, it's not actually going to transform any industries until we start building workflows that help entire enterprises and entire businesses really do something better than they were before and more reliably than they were doing before. Um, when it comes to things like that, it means that just throwing a bigger and larger model at it isn't always the answer. And sometimes we also see things that where a smaller model is the answer. So, for example, I'll give something that's totally off the wall relative to like super enterprise use cases, but there's a video game I've been playing where they're starting to use for some of the non-player characters, they're starting to generate background stories for them using generative AI. Do they really want to be sending for all of those randomly generated characters in the world back to a core model that's like hosted? No, probably not. Like the compute level for that makes no sense, especially in a video game, which is already really taxing on the GPU. So what you want there is a usable LLM that's really small. So that means that each company has sort of been been playing in this model space has different strengths. Not all models are going to fit all use cases, and so that means yes, partnerships have to be the future. Companies talking to each other has to be the future. Honestly, when have we seen a point in technology when that hasn't been true? I
It's
don't see
true.
any
Yeah, it's
reason
very
to
true.
believe that this bit of technology is so different from history.
Definitely. All right. Well, let's end the segment with two quick questions. Mihai, if people want to learn more about this, where should they go?
So we have the white paper out, which you can find on IBM's website. Just search for Architecting Secure Enterprise AI Agents with MCP. I think it's a great read. And
Not that you're biased.
honestly, many of these problems haven't been, not being biased, and many of these problems don't have mature solutions. So if you want to innovate in this space, this is perfect.
Yeah, great. And Olivia, final question, quick for you, is what's the video game you've been playing?
In Zoe.
Okay, great. You should check it out. I'm going to check it out.
Yep.
That sounds awesome. All right, I'm going to move us on to our third topic of the day. We have not talked very much about thinking machines. So we've talked about SSI, and we've talked about a number of companies that have kind of spawned out of former OpenAI leadership. And thinking machines, if you haven't been tracking it, is Mira Murati's, who's the former OpenAI CTO's startup and fundamental kind of research lab. And I want to cover it just because they put out a piece fairly recently that I thought was very interesting and I think is worth diving into and kind of like explaining and parsing through a little bit more. The name of the blog post is called Modular Manifolds, and you can find it on the Thinking Machines website. And I guess maybe to start, Chris, we haven't gone to you because I want to save you to be the leading person on this segment. What is a manifold exactly?
What are you doing to me, Tim? What are you doing?
No pressure. No pressure.
I am not smart enough to answer this question. So I think the quick version of this is when we are training models, right? These models are really, really kind of deep, and we're throwing the entire internet worth of data at them. And then there's lots and lots of layers, right? So it's called deep learning, and the good news is the reason it's called deep learning is because the layers go very, very deep. But as it's training on these models and and they're firing away, basically what happens is the weights of the models change. Now, when we are training the model, small shifts on those weight trainings can potentially send the model off and just basically have a gradient explosion, and therefore it basically trashes the model. And And the reason that's happening, and please don't ask me questions beyond this, but basically what's happening here is the model is effectively on a gradient, and it's a flat surface. So the bigger these shifts, the more likely you're going to get this explosion. It's going to go off. What a manifold is doing is it's basically more running on a curvature rather than a flat plane, kind of like the Earth in that sense. So rather than when you're making those shifts, rather than the effectively exploding off and going off into space, you're staying within that plane, and therefore it keeps the model on track, and that's effectively what's going on. So the best analogy I can come up with is probably gravity, right? Which is, if you think of an astronaut, and the astronaut is floating around in space, and then you push them in one direction, and they could just go off into deep space, and you'll never ever see them again. And what we do is go, haha, we've got a little coil to them, and we'll pull them back in. And that's effectively what you're doing when you're training, right? The astronaut's floating off, and then you pull them off. You're making these quick adjustments. But actually, in my analogy of deep learning here, is we don't need to sort of pull the astronaut back in, because gravity is keeping the astronaut within the planetary space, and they're not going to float off into deep space. So I think I've done a great job of confusing the listeners even more. And if you want to read my book on deep learning for idiots that don't know anything, you feel free to check it out on Amazon.
That was great. I mean, that was brilliant. I was telling all the guests before we started recording that like this is a hard topic, and I'm really interested in like how do we explain this, because I think so often at MOE it's easy to get caught up in like what the apps are doing or what the latest features are. There's some real kind of fundamental research still kind of ticking along in the background that we don't talk about enough. And so.
And Tim,
Yeah.
that's actually just before we sort of jump on there, I actually think that's one of the interesting things that thinking machines is doing. They're taking a really different approach to all the other labs. If you saw their paper on basically how to make LLM, and for instance deterministic as opposed to non-deterministic, one of their blog posts, it feels as if they are fundamentally going back to each part of the training process and challenging the assumptions that we have, and releasing these kind of mini bits of papers that just explain how they're trying to improve thing at the micro level. And I think that's interesting and great. And I'm sort of excited to go, well, if all of these things add up, well, what is their model going to look like at some point, assuming they're going to get there? So I think they're taking an interesting approach, which is a little bit more scientific and engineering focused.
Yeah, absolutely. Yeah, I totally agree. I mean, I was reading it, and actually I have my sort of NeurIPS 2016 mug here, and it was like kind of like a weird like throwback. I was like, oh wow, this is like kind of like much more early days like on the research, whereas like let's just talk about the mathematics of this representation for 90 minutes. And I think that throwback is like, yeah, I agree with you, Chris, is like very, very interesting as like something that's quite distinct as an approach from a lot of the kind of players in the space. Olivia, so Chris has done his valiant best, I think, to explain what manifolds are in the training process. And it feels like, if we can say anything about this blog post is, it's attempting to find a way to do this better. And I guess, do you want to speculate a little bit? I mean, like, let's abstract away all of the kind of technical complexity for a moment. If we're able to kind of like stabilize and use manifolds more effectively, what's that mean for AI? What's that mean for training? What's that mean for fine tuning? What are the implications practically if you're just someone listening to this being like space people being roped back? What does that mean for day to day in AI?
Goodness, I'm not going to say that I know the answer, but just speculating using some very old knowledge, I'm going to say that basically looks like models staying on target better, models keep not drifting off during training quite as much, maybe not being as influenced by the latest data that they're seeing. But honestly, I'm not quite sure.
If you look up close, even the Earth looks flat. And I think the idea here is that you're going to constrain things along that flat plane. And it kind of reminds me of a book I really like, which is The Foundation, where they don't predict every single event. To set humanity on its course, They actually design the pathways in which civilization is likely to move, and then chaos itself can be somewhat predictable. And I think the same is happening here, where instead of just trying random weights in a very high dimensional space, you let them wander around a very, very well-defined plane. Like, take a sphere, but that manifold itself is just a predictable, it looks like a flat plane. So it kind of leads to, I would say, a more predictable path for chaos, if that makes sense.
I think training is really hard. It is as much as we want it to be a science, and it is a science, there's a lot of variation when you're doing that. And anybody who's ever fine-tuned a model will know this, right? And I'm a, part-time fine-tuner hack in the evening. And the sort of things you need to think about is, what is the learning rate for this? How am I going to put the data in there to get the best output from my model, etc. And it is hard to get that right. And actually, to the point, as you're sort of trying to mix all this up, if you put the learning rate, the learning rate too high and it's aggressive, then that's the sort of thing will cause the gradients explode, etc. What we have seen in the past is especially with these big labs, and you'll have heard it before, is that you did a big training run, and then about 3 months in, it goes wow, 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 and it was just like, and every, you had something, it was wrong, and the training run blew up, and you just lost a few $1 million. And that still sort of thing happens today as well. It costs a lot of money to do these training runs. It costs a lot if things go off. So actually, by being able to stabilize things in that way and have things become more predictable, it means the cost comes down, and it means that we are going to get better AI in the future. And to the point, as they're trying to have things be a little bit more predictable and deterministic. So I think that's a big save, is we're going to get more AI quicker, better, and more reliably.
Yeah, absolutely. Yeah, that's kind of how I thought about it, was like, if you think about these training runs as kind of these rocket launches, and it's just like, it has to be a really precise thing or else it kind of breaks at huge cost. It's like,
and
kind of what this is doing
floats
is like
off into space.
And that's like you were saying.
And you brought it back to my analogy, Tim.
Yes, exactly. You're welcome. That's where I was headed. So. All right, last topic of the day I want to talk about. So there's a great publication called Works in Progress. They do a bunch of interesting investigative reporting, research effectively on technology and how it happens. And this story entitled "The Algorithm Will See You Now," which published a few weeks ago, authored by the name of Deena Mousa, really caught my eye. And this article does a pretty simple thing. It basically says, look, a few years ago, there was a lot of hype that computer vision technologies were going to replace all radiologists. The idea was, well, look, what does a radiologist do? They look at a scan and they try to find anomalies in that scan, and they label that scan, and that's what they do. And so surely, with computer vision, radiologists are going to be the first job to get replaced in the AI revolution. And the paper just says, okay, the article just says, like, let's take a look at what happened. And what's interesting, and I'll just quote really here, is that like things have actually moved not just in a flatline direction, but like in the other direction for radiologists. So, quote, "Demand for human labor is higher than ever. In 2025, American diagnostic radiology residency programs offered a record 1,208 positions across all radiology specialties, a 4% increase from 2024. And the field's vacancy rates are at an all-time high. And in 2025, radiology was the second highest paid medical specialty in the country, with an average income of $520,000, over 48% higher than the average salary in 2015. So this is kind of a really interesting anomaly, and I think violates, a lot of our sort of anticipations, assumptions about what AI is going to do to the job market. Mihai, I see you already going off of mute, so I'll let you just get the hot take in first here.
No, I was just saying, wow, I mean, the wrong profession. What was that salary?
Yes, go 520,000. You should have become a radiologist.
Okay.
But like, why is this? So like, not only is the comp going up, but demand is going up even in the same time. Computer vision models are incredible now, right? And so what do you think is happening here?
I think part of it is just the human interfaces, which is no matter how good an AI model is going to be at doing the job of a cardiologist, they can only work through the interfaces which are provided to them. They don't have senses, they can't speak, they can't interact with the patient, they can't interact with other doctors, they can't leverage their previous expertise with that particular patient. And unless something has been either written down or has been built into an agent where every single input and output is defined, they're not going to have the same data as a real human doctor. And who's going to go write that data? Are you going to have nurses running around and saying, oh, can you describe everything? Does this hurt when I touch you here? The AI agent is saying, or the model is saying, oh, can you please give me a bit more about your background? Has your mother had similar issues? So I think part of it is establishing the right interfaces and establishing trust. And no matter how you look at it, an AI model is never going to be able to fill in that role. It can maybe enhance or give a second opinion or work together with a cardiologist to help, I would say, provide a second verification layer to their um, assessment. But I don't think we're at a point where we can say, no matter how good these models can be individually, that they're going to be able to replace all the human interface things that these folks are doing.
Olivia, do you have any reflections on this piece? I mean, I guess one of the questions, just building off of what Mihai said, was like, okay, well, maybe the history of this is, computer vision didn't have this effect, but even Mihai said it himself is like, well, we didn't have an agent that would go ahead and collect all this context and be this interface. Is this kind of maybe a temporary phenomenon? Like, could I say, look, as agents get better, radiologists really are going to be in trouble?
I think that's hard to say, especially because you're not just talking about diagnostic accuracy, but you're also talking about trust and whether or not we can actually put critical decision making in the hands of machines. And I think, as a society, we absolutely have not settled on an answer for that question. Um, Classically, I think, yeah, the limitation of machine learning to solve these problems has been the bigger issue. I think the first time that I saw, can we replace radiologists? A lot of the points that they made were basically that the scans that they were using tended to have like the same, they were all from the same hospital, so they had certain things on them that were causing it to use absolutely the wrong features to differentiate. And I do think, in more recently, when you look at the way LLMs are doing things, yes, they're able to get this kind of diagnostic accuracy a little bit better. But I think in general, you're always going to end up doing the low-hanging fruit with machine learning before you're able to replace experts. So if we want to build systems that we have trust in, then those systems should be doing things that only they have extremely high confidence in, and the difficult cases should be left up to really, to humans who have the ability to bring in more data than you could ever build sufficient integrations for an agent. I think if we were talking about a world where, yes, we truly have AGI, then maybe it's a different story. But I don't think LLMs today, and granted, this is a personal opinion that is widely debated in the field, I don't think LLMs today represent that AGI.
I think you're spot on, Olivia, on today's, but I think there comes a point when we know the AI is better than the humans, then we should be handing over some of that. And I know that sounds really harsh, and it's definitely not an IBM view, it's a Chris view. We're going to clarify that right now. But let's imagine this for a second, right? Let's say you want to play a game of chess, right? Tim, who would you rather play at chess? Would you rather play Magnus Carlsen, Magnus Niemann, or would you rather play Stockfish? Who would you rather play?
I mean, if I had a choice, I guess Magnus
Just
Carlsen, right?
great.
For the
Now, the
experience of
future
doing
of
so?
humanity, we're going to have a chess game. It's going to be you versus the alien, some alien that's come from a different planet. And it's either Magnus Carlsen or Stockfish that's going to take them on. And by the way, whoever loses that game, the planet is gone. Are you choosing Magnus or are you choosing Stockfish?
I guess Stockfish then, right?
Exactly. And then therefore, I think there comes a point where you're using AI for entertainment, and that's fine, or you're using it for productivity. But there comes a point if something is better and life is hanging on a balance there, you should be using the absolute best tools that you've got at your disposition at that point to be able to solve that problem. And I agree with you, Olivia, completely 100%. We are not there just now, but there will come a point where we are there. And therefore, the moral question will come around to is actually, should we not be putting that in the hands of the AI versus the human, because the AI is going to get it right more times than the human is. And we're not there yet, but that question is going to be coming.
I think I fundamentally disagree, and I think it's because machine learning is fundamentally probabilistic and humans are not. And so I think there is always going to be an error rate with machine learning techniques as they have currently been developed that I think it is highly unlikely that we are ever able to fully account for that. And I think that would have to be some kind of other advance, some kind of other technology that would allow an LLM type technology or a machine learning type technology to act like a human and have actual like conscious decision making. So I don't think it's a matter of of what's the best. Radiology fundamentally is subject to interpretation to a certain degree. So I've recently had to get scans on various things. And the thing I've noticed is that one radiologist will look at the scan and say, hey, I'm noticing this one thing. The other radiologist will look at the scan and say, hey, I see something different. And one thing that one of my doctors pointed out recently, we were looking at a spinal image who said, I'm actually not sure personally whether this is T7 or T8 because I don't know which one we're looking at. And the only way you could know that is by talking to the original imagers and say, okay, where was this person positioned? How can you tell the difference between these vertebrae? So maybe you can imagine an agent being able to do that, but the amount of data that you have to pull in order to make that decision as best as possible is actually not as trivial as we think. So it's actually a huge engineering challenge to bring sufficient data to replace radiologists.
It's context, communication, and accountability. But we also have to look at bugs, vendors, and hackers. So, for example, one of the healthcare systems here got hacked and it took down the whole system for more than a year, where every system had to be disconnected because most of the systems were still running on Windows XP. And the moment they got networked, they got crypto-locked. And all the radiology equipment, everything had to go through human doctors. They would be disconnected from the network. You would go in, you would do something, you'd write that down, you'd take the note, you rip it out, you give it to the next doctor, and so on and so forth. So even if we want to do this today, I think it will take more than 50 years, 50, to roll it out in a well-governed way to all the hospitals in major, well-developed countries to the point where it can be reliable enough. And if you don't have your radiologist to fall back to, those systems are going to continue to remain vulnerable to hackers, to vendors who are going to say, oops, we're going to turn off your cardiologist if you don't pay your your token bills. So I kind of see a system where it's not going to be hybrid, where the AI is going to provide a review or help with things like triage or measure objects or give a second opinion, but the accountability and the context and communication will fall into the hands of the human.
Well, we'll have to see. I think we're going to check in basically. If we're still running at that point for MOE in a few years, I do want to revisit this again and see sort of where we are, because I think everybody here has kind of put out quite different visions of what might happen in the future. And I think it kind of points to just ultimately how uncertain some of this all is. Well, that's all the time that we have for today. Mihai, Chris, good to have you on the show as always. Olivia, hope to have you back at some point. Thanks for joining all you listeners. If you enjoyed what you heard, you can get us on Apple Podcasts, Spotify, and podcast platforms everywhere. And we'll see you next week on Mixture of Experts.